An AI confidently tells you the wrong answer, and it has absolutely no idea it just did that. Large language models can state false things with total confidence. Researchers call this hallucination, and it happens because of how these models are built at a fundamental level. A language model is not a database. It does not look facts up. Instead, it learns patterns across billions of pieces of text and compresses all of that into a giant set of numbers called weights. When you ask it a question, it predicts the most statistically likely next word, then the next, then the next. It is completing a pattern, not retrieving a verified answer. The problem is that patterns in training data are not the same as truth. If a false claim appeared often enough in the text the model learned from, the model treats it as a normal pattern worth repeating. There is also something called the long tail problem. Obscure facts appear rarely in training data, so the model has weak pattern support for them. It fills the gap with something plausible-sounding instead. The model also has no internal alarm that fires when it is uncertain. It produces output the same way whether it is on solid ground or completely guessing. One technical fix is called retrieval-augmented generation, or RAG. Instead of relying only on its weights, the model is connected to an external knowledge source. It can actually search at the moment you ask a question. The model pulls in relevant documents, reads them in real time, and bases its answer on that fresh material. This keeps factual answers grounded in something checkable rather than just pattern memory. Another approach uses knowledge graphs. These are structured maps of facts and the relationships between them. Connecting a model to a knowledge graph gives it a more reliable structure to reason against. Researchers are also working on better calibration, which means training models to express uncertainty when they should. A well-calibrated model says something like probably or I am not sure, rather than stating everything with equal confidence. There is also a technique called chain of thought prompting. Asking the model to reason step by step before giving a final answer tends to catch some errors that would slip through in a single-shot response. None of these fixes are complete solutions on their own. Active research is still figuring out which combinations work best and in what situations, so this is genuinely an open problem. The core tension is that the same statistical pattern matching that makes these models so fluent and flexible is also what makes them capable of sounding convincing when they are completely wrong. Understanding that the model is a pattern predictor, not a fact checker, changes how you use it and what you trust it with. If you want to go deeper, the topics of model calibration and retrieval-augmented generation each have a lot more going on under the hood.